So our next presentation is going to be Caitlyn, who has been in our program for about 2 years and has one more semester left. Actually been working a lot with Mo on a little bit of precipitation and streamflow analysis, focused a little bit on Detroit and coastal Georgia. This is actually based on a NOAA project that Ricky is the PI on, and we'll eventually be building up a community interaction component. And this is sort of laying some of that groundwork for what will eventually be done. And I think this is an ArcGIS story map that Caitlyn produced. And so this is kind of a new type of product for us, but I thought we were talking about it. We thought this might be a good way of making kind of some of the information a little bit more available to a wider audience. So go ahead, Caitlyn.
Yeah, hi. So I'm going to be presenting on Detroit watershed and coastal Georgia precipitation and streamflow spatial analysis in correlation to property flood damages, primarily using mapping techniques. And I'll do this using NOAA precipitation data, USGS streamflow data, and FEMA flood damage data. I'll also be connecting this later on to census incomes after completing a short probability analysis, which determines the future frequencies of the most minor or extreme events of max daily precipitation, max daily streamflow, and FEMA building flood damages. All right, so a lot of the first semester work I'm going to skip over just for time's sake. Most of the assertions or conclusions from looking at statewide Michigan and Georgia maps are either proven or disproven when scaling down to Detroit watershed and coastal Georgia. Okay. All right, so for the Detroit watershed, we're going to stay within the Clinton River and Rouge River watershed basin boundaries. For coastal Georgia, we stay within Low Savannah and Agachi watersheds. And these are all the streamflow stations below here and just info on where the NOAA data came from. And one reason we stay within these boundaries are because we wanted to include McIntosh County, which was mentioned as an area of interest in a partner meeting with University of Georgia, as well as the Detroit watershed connects to current GLISA flooding proposal work. These are just stations available within those areas that were used specifically for streamflow data. By zooming in on the FEMA reported building flood damage locations for Michigan and Georgia, which are seen here, we see that our data will be based on gridded data, which kind of appears like a chessboard you can think of where points are right next to each other. So this means we are relating stream discharge and precipitation back to locations of individual buildings that reported flood damages to FEMA from 2001 to 2024. In our results, we reconstruct time series maps of precipitation and streamflow for the Detroit watershed and coastal Georgia, which are seen here. I'll just play one of these quick. So Detroit has consistently much higher streamflow values due to its drastically higher water volume capacity. And this is compared to other areas like the Eckersay River at Dearborn Heights, which have a much lower volume capacity as they're much smaller local streams. We see minimal spatial variability in max daily precipitation amounts over most of the year range and locations, and all stations being at about the same level for a particular year. The few times this doesn't happen, one station recorded a much higher level. We disproved that our statewide conclusion holds, which is that high precipitation is linked to close geographic areas over short time frames, especially as most historical values were below 3 inches, only reaching 6 inches in 2003. The Savannah River at Fort Pulaski in Georgia exhibits much higher streamflow from 2010 to 2024. For a few years, we have negative discharge values recorded, which means the stream gauge is below the given datum or zero elevation level for that region, which is sort of an average elevation for the whole area, which can be local or global. This doesn't necessarily mean that the stream is dried up or empty, and we'll explore this further when we look at flooding data, or I should say flooding damage data. The Savannah River, the low Georgia spatial variability in 6 years occurs. And in 2006, we have one location recording the highest possible value at about 3 inches, and all others are below 1 inch. This pattern of 1 or 2 high max daily streamflow values and then comparatively low values at all other locations repeats a lot throughout the year range. And we have contrasted our above statewide assertion that Georgia max hourly precipitation exhibits much less spatial variability compared to Michigan when looking at smaller scales. All right, so now we're going to get into the FEMA data. The top 3 instances of building flood damages were tabulated for Detroit watershed and coastal Georgia. These instances are US dollar amounts of damages to individual buildings that are sort of combined per recorded zip code defined in these locations. And this is also cumulative over our year range. We find that Warren, Royal Oak, and Canton had the top 3 building flood damages for Michigan in the range of a few $100,000. In comparison, Glynn County had the 2 highest flood damage values at about $500,000. Glynn County had the top 3 coastal building values at about 30 million and 2 of the lowest valued properties at $0, as well as many others at $0. All top flood damages occurred in the same year, hinting at a major amount of surface groundwater flooding in 2016, which is going to be explored in our further analysis. All right, so we've shown areas of highest and lowest valued buildings can experience the greatest dollar amounts of flood damages. Due to Georgia's top flood damages being within 2016, not only is precipitation over a short time frame present, but also flooding damages over a short time frame for coastal Georgia specifically. Now we're going to get into our probability analysis, where a cumulative distribution function was made for max daily precipitation, max daily streamflow, and cumulative FEMA building flood damages. These curves are the probability that one of our 3 variables will occur less than or equal to their historically observed values. We highlight under these curves, as you can see in green, yellow, and red, for areas of minor to extreme events, damages, etc. And by integrating under these curves, so you can just see some examples here. There's a bunch because we have several for each variable. All right, so by integrating under each cumulative probability curve for the greatest and least sections of intensity percentiles, meaning minor and extreme events, we create index values which are used to calculate cumulative probability indice values. Indices displayed as horizontal bars have 2 outcomes. So either the CPI value is positive, meaning minor precipitation, stream discharge, or building flood damages exceeds extreme levels. As indices become more positive or closer to 1, a greater degree of minor precipitation, stream flow, or building flood damages will occur. And then if it's negative, we have the opposite effect, where extreme precipitation, stream discharge, or building damages due to flooding exceed minor levels. As indices become more negative or closer to -1, a greater degree of extreme precipitation, stream discharge, or building flood damages will occur. CPI values for building flood damages are negative except for Harrison, Michigan. Its small positive value indicates moderate future levels of extreme building damages, still totaling greater than $50,000. On the other hand, all other areas for Michigan and Georgia should expect greater chances of low damages in the future, less than $50,000. An amount that's still detrimental to property owners like low-income owners or small businesses that we'll explore with the census data further. We consider frequent minimal flooding related to frequent minimal damages as nuisance flooding. Coastal Georgia and the Detroit watershed have max daily streamflow CPI values of small negative degrees and very minimal extreme max daily streamflow is expected. Yet flooding damage levels and minimal streamflow levels indicate otherwise. There's enough volumetric velocity to affect infrastructure when mixed with flooding from sea level rise that at a minimum still reaches 30,000 cubic feet per second. Okay, max daily precipitation CPI values are all positive but far from 1. indicating moderate future levels of extreme max daily precipitation. This is based on historical precipitation only reaching 3 inches, which is still enough to seep into infrastructure or accumulate in overwhelmed storm drains. Coastal Georgia should plan for higher days of extreme max daily precipitation. By our probability curve, the levels are capable of a foot of water. Due to Georgia having less precipitation spatial variability, as we showed before with the maps, then we now know a foot of water of precipitation is expected in close areas, which is seen where 2 of the airports are only an hour apart, recording a foot of water for the future in high frequency. So now we find if areas of most frequent minimal extreme max daily precipitation, max daily stream flow, or flood damages correlate with wealthy or low-income areas, determining whether our earlier predictions are capable of causing significant household impacts to low and middle-class families, or if these areas are primarily wealthier. So these are just some pie charts of household incomes, and they're inflation adjusted and recorded for the 2022 census to connect to current information as we're doing future predictions. We find that Canton and Warren's highest building values are in the 3 to 4 millions in Michigan, as well as Savannah, Brunswick, Chatham County, and Tybee Islands in Georgia. Glenn County, Georgia's highest building value, was at $30 million. Detroit, Dearborn Heights, Harrison, Glenn County, Savannah, and Chatham all have lowest building values of $0. We attribute then high property values resulting in higher incomes and thus higher building flood damage costs. An example from our analysis supporting this is that Canton Township is a wealthier area with 20% of household incomes over $200,000. However, we end up showing that a presence of income disparities through highly variable incomes in the same locations is present. As an example, the top household incomes in Detroit are at $50,000 to $75,000 or less than $10,000. And most family households only make $35,000 to $75,000. Detroit and Dearborn Heights, Michigan, Savannah, Glenn County, and Elma, Georgia had some of the nearest precipitation CPI values to 1, meaning there will be more frequent extreme max daily precipitation in the future. Therefore, households there should prepare for possible foundational damage as precipitation can accumulate in overwhelmed storm drains, as we already stated, helping increase flooding likelihoods for already prone high flood damage areas, and where we now know there is a significant percentage of lower to middle class incomes. Garden City, having one of the closest streamflow CPI values to -1, indicates a potential problem. With minimal future streamflow, even a small rise in sea level from the Rouge River, for example, due to climate change, could cause an increase in flooding for the area. These areas of low to middle incomes and a range of building values, as we've shown, are more quickly affected by frequent minimal streamflow, worsening frequent minimal flooding or nuisance flooding with sea level rise off the lake. And then earlier we noted that all top flood damages in coastal Georgia occurred in 2016, hinting at a major amount of surface groundwater or flooding. And we're going to explore this with further analysis due to a lack of flood stage data. So we can employ Google Earth Engine to make maps of floodplains for small areas using high resolution data sets that are both available for Google Earth Engine or through community catalog websites. So here we see ground surface water changes for 2016 that had the highest building flood damages occurring. And these are broken down by type, and then a water mask is applied to remove unwanted water features that are maybe misclassified. You can also use masking to remove cloud cover if working with other types of satellite imagery. And we use this to create a chart of how the water occurred in 2016 that had the high flood damage amounts. So we see most of that is permanent or seasonal transitions of water. So therefore we can attribute seasonal causes to building flood damage amounts in high amounts in these areas. And this is just an example of the floodplain and building footprints for the year, where you can zoom in and just really simply adjust opacities and see the extent of the floodplain to infrastructure areas, such as this area as a Southern Georgia University campus. We can also further analyze by not just taking census data for the top locations of FEMA flood damages, our most frequent predictions of minimal or extreme variables. We can also look over all locations and synthesize data that way, which I mostly just didn't do in lieu of time. And then just some ideas for GLISA and University of Georgia to implement primarily is collecting flood stage data that's unavailable at small scales and created a pretty big problem when I was doing probability analysis. This can pretty easily be fixed by adjusting current stream gauges to also record flood stage data, which other states are already doing. You can also employ thermal sensors, which are handheld devices that cost about $100 to $500 range. And these can be used with a physical person walking around in locations of high flooding to find those high flooding locations with the thermal sensor, similar to how you can use them to find heat sources within buildings. Just some learned outcomes, obviously data availability, huge issue. And then strategizing research outcomes between partners requires a lot of time and rescoping of projects in general. And combining data dependent on flooding and satellite imagery with remote sensing techniques as a dependable workaround for data availability issues at smaller scales. This is just a table of results and whether they're proven or disproven or both. And we got some sources. And that's it. Thanks, guys.